Excellent, very good. Thank you very much. So thank you very much for the opportunity to be here with you. And it's a great pleasure, especially the fact that I'm also very interested in kind of contributing to the fight against climate change. Is probably one of the biggest challenge that we are facing as a humanity. And so it's a great honor to be here and providing some contribution to this important topic. Now, my name is Stefan Dittforth, and I'm a senior solutions architect. I'm based in the Middle East. I live in Dubai, in the United Arab Emirates, and that already since 11 years. So I'm quite familiar with the region. I also traveled and worked in Egypt for quite a while. And and my kind of the theme or the topic for my talk today is code against climate change. And the reason I picked this, when I was preparing for this Climathon, I learned that a lot of students will participate in this. And I hope with this talk, I would give you some ideas, inspirations, how these skills, technology skills, coding, data science, how that could help with you being a good contributor for the fight against climate change. Now, where can you actually use that skill? And one of the things I would like to draw the attention to is the aspect of, let's say, measuring things. And that's, I believe, is particularly important when it comes to climate change, because climate change is a very complex, let's say, behavior or complex process, and we do require data to make sense of it, and we do require data to influence the behavior of people, to influence decision makers in the choice of technologies and the choice of selecting and deploying technologies, and also unearthing or finding new ways to address carbon emission, reduce carbon emission, and also then basically reducing the impact on the climate. And I wanted to make this tangible, this kind of demo. I wanted to run this a bit more like a demo. So what I'm going to do is we take a particular object that we will look at, and we will write I will show you some small code where we collect data and then visualize that and then draw some insights from that. And the object what we're going to use in this session is this house here. This is actually my brother's house in Germany, and he built this house about 10 years ago. And like me, he's also very interested in technology, and he also often thinks about his impact on climate. And when he was building this house, he was thinking a bit about how can I get a view about the energy that I and my family living in this house are using, and are we using this in an efficient way? So quite early on, we started thinking about how do we get this data to understand that, to understand his behavior and everything in this house. So what we did, we deployed this small Raspberry Pi in a small, let's say, cabinet in the attic of his house, and we used this Raspberry Pi now since I think it's 8 years now, and we're collecting data from various devices in the house. And one of the first things that we connected is this electricity meter that you see here, and it has this little box attached to it, and that's essentially kind of a data capture device. And that was necessary because the meter itself didn't have an easy way to collect the data, apart from you go there once a week and you write down the current reading of your current, let's say, electricity consumption. But that's not a pretty sophisticated way to get a good insight about how do you use electricity. So he basically got this additional device, he retrofitted this, and actually the installation is very straightforward. You just attach it to it, so you can pretty much retrofit this to any existing electricity meter, and then it would start collecting data. And it has a little Ethernet connection cable to it, and then you could basically address this with a small web address or IP address, and you could get all the data from the device. And the reason this works so well is if you look on on this electricity meter, it has this little, I mean, currently it's black, but this spot here is kind of a little LED, a light emitting device, diode, that kind of blinks in regular intervals, and one blink is equivalent to a certain amount of energy that you have consumed on this device. And this kind of pulse is very common. I mean, this is used internationally by all these electricity meter devices manufacturers to indicate the usage of that the device is active, and that's basically what this little plugin makes use of to collect this data. So that was the first way of getting hold of the electricity data. The second thing that we were interested in is this big device here that's also in his house. That's essentially the HVAC system, the heating, ventilation, and cooling system. And that's a pretty big kind of cabinet type of things, 2 meters high, 1 meter 50 wide. And it makes sure that the house is warm in winter, cool in summer. It heats up the water for the shower. And so that's also one, let's say, device where the biggest chunk of energy is being used. And it's kind of smart because it has a little web server where you can essentially go on, and then you get this login screen, you log in, and it shows you quite a long list of various parameters related to this. And we were interested in particular 2 values. This one here, this shows the energy that has been used for heating per day. And the second one is the energy recovered from ventilation. So just to explain this a little bit. So when you heat up a room in winter, and you bring in fresh air, you heat up the fresh air, and then you pump this into the room with the air conditioning system. There's also, let's say, used air that's being moved out or sucked out of these rooms, from the kitchen, the bathrooms, and so on. And that used air usually is pushed out to the outside. Now, it has this used air has something very precious, which is energy from it's already warm, so it would be a shame if you just waste this to the outside and not trying to recover that heat that's already in that, let's say, warm outside air. And the air conditioning, the HVAC system, has a certain component is called a heat exchanger that allows to recover heat or energy from that outside air. And the value, how much energy that is shown in this second value here. And what we were asking, my brother and I, what we were asking is, so over the course of a year or a month, how much do I spend for heating? How much does this device actually recover? Because that's a very interesting discussion, because that recovery actively contributed to the reduction of carbon footprint, to the reduction of an impact on climate change. So that was actually a good value to look at. Unfortunately, our challenge was that the device itself just presents the current data, but it doesn't allow to store this data in, let's say, regular intervals, once per day or once per week, so you could kind of get a view over time. And that's where we kind of developed code. That's the one I will go and show you how you can write code for this kind of activity to collect data either from a web interface if the device has this limitation and it doesn't have a machine-to-machine interface, or you have something like this more suitable device, which allows already kind of a direct machine communication. So you will see that when we dive into the code, that there's a very different approach to that. Now, so this is just an overview about what we're going to see in this demo. So we have the Raspberry Pi here. We write some Python script, and that Python script basically goes to the electricity meter, collects data, and it takes a different approach to collect data from this web interface of the HVAC system. And then what it does, it pushes the data to the cloud, in this case to the AWS cloud. And from the AWS cloud, we're going to use a specialized database. and that's called Amazon TimeStream. Now, Amazon TimeStream is a purpose-built database for time series data. And the kind of data we are collecting here is perfectly suited for that purpose. So we will, I mean, in a kind of a more permanent installation, you would trigger and run this Python script probably every 5-10 minutes, 1 hour, depending on how granular you want the data. You collect the data, give it a timestamp, write it to TimeStream, and then you can use that for further analysis. Time series data is very different from tabular data. So tabular data would be, for example, let's say the list of attendees in today's presentation. You have names, university, where you're coming from. So that's very tabular oriented. TimeStream is very specialized for data that's basically placed along a timeline and that you want to analyze along a time. Now, once we have the data collected, we want to visualize it to, first of all, getting an impression about the nature and the pattern of the data, but also to basically visualize it. And this is where we're going to use the Amazon Managed Service for Grafana. That's a nice visualization tool. Grafana is a very popular software that allows you to build beautiful dashboards, visualizes data, and is very perfectly suited for time series data. It originally comes from IT operations, or DevOps, as this is also called, and is being used to present parameters of applications, servers, and so on. Okay, let's write some code. So let me bring up my development environment. So first of all, I would like to show you how simple it is to get some data from the electricity meter. And just to give you a first impression, so what I can do, I can use a command line tool called curl. That's a command line tool to retrieve data in a Linux command from internet sources. And we use the same command to query the electricity meter, and it provides us a number of parameters, but the one that interests us most is the counter, and that's essentially the data value that we are looking at. That's the amount of energy of electricity that has been consumed already. Now, I've done this now in a command line, but now I would like to do this in a Python script. So let me give you a code snippet how that is being done. So what I do is I simply use a Python library called request that allows me to do get and post requests. You might have heard about this as part of an IT computer science course. And I can provide the address of the website, the device that I want to get data from. And that's what we do. So we just say, give me your current data, store this in a variable, and then I just basically kind of format that a little bit, and then I let it print out the results. So let's run this. If I now run this Python script, the very short one here, it should print out, yes, excellent. So it prints out the current timestamp. By the way, this is German time zone. Don't be surprised. Oh no, for Cairo, this should be exactly the same. So, and because we are actually live on this Raspberry Pi in Germany, and we're now getting a current reading of the electricity consumption. And if you run this again, you will notice the value increases. So it's actually really getting the live data from the electricity meter. And now we have done the first step. We basically got the data. It now sits in my variable consumed electricity. Now I would like to push this to the time series database. And for that, I first need to configure my access to the AWS cloud. This is what I'm doing in this line here. I'm basically connecting to the AWS cloud, the data center or the region in Frankfurt in Germany. And then I say, in Germany, I would like to use the TimeStream database service. So I create kind of a client object that I can then later use to write data to. And the other two parameters I'm specifying is the name of a database and the name of a table where the data needs to be written to. And then I'm pretty much ready to actually write these records, create a record and write that to the database. And in order to build a record for time stream, I need to put this in a certain structure. I have to provide so-called dimension. Dimension is basically attributes that you want to attach to a certain measurement. So in my case, because I have only one home with one electricity meter, I just add the attribute device type as an electricity meter and the name. So that's my home electricity. But imagine if you are collecting tens, hundreds, or hundreds of thousands of devices, you have additional attributes, for example, location, city, district name, or let's say to which energy supply company that belongs to. So you could have a long list of attributes, and then in the database, you could use these attributes to search and display data. But for our simple case, we just need 2 attributes, and I have to provide the measured value. What is it that I want to say? Does my consumed electricity? And a timestamp. So I have to format that in a particular format, and then I'm ready to go and just executing this write command, and then I'm ready. So let's run this. I get some electricity data. So, and it now has been written to time stream to the database. And let me just write another one just to have a few more data points. So now I've basically done the second step. I wrote the data to the time streams database. And now let's have a look. How do I visualize that? How do I build a nice looking dashboard for that? And for this, I will log into my AWS console that gives me access to all the different services that I have in available in the AWS cloud. So there are over 200 now that we have. And what I'm interested in is this Amazon Grafana service. So this is the service that allows me to visualize. And let me switch to that. And I have already prepared a so-called workspace. So I just log into this, and I should be presented with the landing page for Grafana. And what you do in Grafana, in the visualization software, you build so-called dashboards. And a dashboard is a collection of one or more panels, and each panel can have a different graph, different charts, and so on. So what I'm going to do, I'm just building a very simple panel. I go into this dashboard for Climathon, and I just add a new panel. And by default, it gives you a very simple sample panel called Random Walk, where it presents some random data, so you get an idea how it looks like. And but I don't need this, so I delete this. And then what I do is I'll say all my data sits in time stream. And let me move this up a bit. I have stored this in the Climathon database, and I created a table, smart home demo. And I'm interested in electricity consumption. By the way, smart home demo, that's the one I referred here in my program, Python code here. And the measure name, electricity kilowatt hours, that's the one that I'm referring here now. Now, what I need to add here is a query statement whereby I query time stream database to get data back that's then being visualized here on this panel. So let me just take this query and add that in. And let me make this a bit bigger here. Yeah. Let me just quickly, you can see that's already showing some data. This is the 2 or 3 data points that we added in when we experimented with the script just a few minutes back. So let me just briefly explain what I did here. So some of you, if you study computer science, you probably have worked with SQL, standard query language. It's a very popular language to query data. And it's also a very valuable skill to have, to know how to work with SQL, to basically create statements to query data. And it's very powerful what you can do with this. And what I'm saying is here is, give me all the device names that match home electricity and create a time series over the measured value. That's my electricity kilowatt hour. That's what I pushed in here. And then this is essentially the result that comes back from that. So if I look at this table here, you see here the values consumed home electricity that we have pushed in our test in the last few minutes. And then you can visualize that. So let me just do one thing. I just do I'll make it a bit smaller, the last 30 minutes and up to 10 minutes in the future. So what I can do here is I apply a time range of what I want to see. So I'm just adjusting my time here a bit. Let me just make this a bit smaller, 10 minutes. So I'm looking at 20 minutes and the time now should be roughly in the middle. Now, what I'm going to do now is, let me apply this, and then I go back to my code, move this over here, and let me run this again. I'll just push in another data point, and that should actually then show up here on my dashboard. Yeah, exactly. So that's the data point that we just pushed in. So you see, this is fairly quick, given the fact that the Raspberry Pi that's writing to the time series database is sitting in a different city in Germany. The data center is in Frankfurt, and I'm watching this from a web interface in Dubai. So it's very responsive, it's globally accessible, and by the way, this is the power of using cloud technology. You can very quickly stand up these kind of visualization of data. Okay, now you have seen how we collected the electricity meter data. Now let's move back to the HVAC system that has this interesting data, or the data we are interested in about heating and the energy recovery. So let me go back to my development setup. Just need to rearrange this. Yeah, okay. So for the heating one, just to recap, the challenge that we are facing with the HVAC system was that the data is not so easily accessible like for the electricity meter, where you simply send a get command to it, and the response from the electricity meter is very easy to digest. You get a data structure back. That's very easy, where you simply say, okay, off the data, I just want the counter, and boom, you have the number. The HVAC system, unfortunately, only has, let's say, a human interface, so a website where you need to log in. That's the first hurdle we need to overcome. And then you have this presented in a kind of a formatted structure where you then need to pull out the data. But Python has a very powerful library that allows you to address that. And the way this is done is you make use of, hold on a second, that was not all I need. You make use of a library called Mechanize. And what Mechanize allows you to do is it allows you in your Python code to simulate a browser. So it's a browser that's not visible, so or it's often called a headless browser, but you can kind of automatically control, like as you would do as a human being, with pointing and clicking and entering information. And that's kind of the key library that we're going to use to essentially navigate the web page and pull out the data we are interested in. So the first thing we have to do is we have to create a browser object. And then in that browser object, we have to navigate to the login form. And here's where you usually, when you're faced with these kind of challenges, you have to do a bit of a kind of a research. You need to understand how is the structure, or how is the HTML code and the structure of that web page. So what I have here on this tab, let me just minify the terminal. What I have here, I have the HTML code of the login page. It looks like this. And so what I'm looking for is the login dialog. So let me go down. That's a bit further down. Let me just jump there. So it's basically this part here. So there is basically a form on this website that essentially has asked for the username, and it asks for the password. And then it has basically a button that you click. And this is HTML. This is basically the descriptive language that describes how this login page should look like. And basically what we're looking for is the name of that form, and that's what we're going to reference here. So we say, find this form and then make that the current form, and then we enter via our Python script. We injecting the user ID and the password, and finally we press the submit button. So we have basically automated the login to this web page, and then we can navigate to this page that has the values that we are actually interested in. And that's what we're doing here. So we're now basically opening up the website that has the measurements, the measurement values that we are interested in, and we pull in that data, and that's the raw text of the HTML code of all these measurements. And again, that's the HTML code. And if you look here, it has this word Heizentag, means in German means heating day. So let me just search for that. So that's the one. That's the element in the HTML code that contains the measurement I'm interested in. That's the 0.755 kilowatt hours. That's what I would like to pull out from this long text structure. And the second one that I need is this one here, the recovered energy per day. And you can see it's part of a larger HTML structure. So what I'm essentially used to pull out this data, I make use of an approach or a technique called regular expressions. And if you're getting into, or let's say if you learn coding, this is a very powerful skill as well. And that basically allows me to pull out the right value, and then I can put this basically into a variable called heating, and then another variable I use for what is the energy that I recovered. So I use this regular expressions to find the right place and pull these numbers out. Now that I got these two values, I can then, again, as before with the electricity meter, I just also collect a timestamp, and then I build my record for the storage in the time stream database. And now I need to create two records per measurement. So one is for the heating, the amount of heating, and this one is for the energy recovered. And that's like before with the electricity meter. I just write that to the time series database, and then I'm good. So let's run that. So you just get a feeling how that looks when you execute this script. So in this case, it's called get heating data. The other one before was get electricity data. So we run this, and oh, I have a typo in here. So did I something wrong? Let me just quickly. Oh yes, I played around with this as I was talking and entered and added a syntax error. So let's hope this works now. Yeah, looks good. So luckily this was the only typo. So now you can see that I got the amount for heating and the amount of the recovered energy. That's nice, and it's pushed to the time stream database. So again, let's go back to our Grafana dashboard and let's look at the visualization of this data. Now, in order for that data to make sense, is you actually need to collect data over a longer period of time. So, I mean, we have now only pushed in a handful of measurement points, and there's not much you can see with that small amount of data. So what I did is, in preparation for this demo, I created another dashboard and I preloaded some of the data that we already collected over the last, I think, 1 or 2 years. And I used those data to build, let's say, a longer period kind of dashboard. And that looks like this. So first of all, I need to select, because the data only goes up to the end of August, I need to choose a time range where the data is visible. At the moment, it's set to the last 6 hours, but I have no historic data. I have only data up to the end of August. So let me do one thing. I will just switch to August and say, show me the data for the whole of August. And it then populates this chart. And by the way, this is historic electricity consumption data, just to see how it would look like if you had collected 1 month of electricity consumption data and then you visualize that. And the beauty about Grafana is you can then start zooming in. For example, if I'm interested in 1 day, so let's say I look at the 5th of August, 1 day. So this is energy consumption, electricity consumption starting at 5th of August, around about midnight, and that goes up to the end of that day, midnight. And you can see there are these common spikes here, for example. This is 9:25 in the morning. This is typical when you go to the kitchen, cook your coffee, prepare your breakfast. You have another spike here in the evening for dinner, another one in the middle. This is likely in the afternoon when you come back from work and school and prepare a small lunch for yourself. And so that's now where it starts getting interesting. What kind of insights you can gain from that data? And for example, when you look at electricity data, as expected, during nighttime, so this is this period here on the left half, you would obviously expect a very low electricity consumption, and that's usually the case. Now, if you think about climate change, avoiding or reducing carbon footprint, one thing that you could, for example, do here is you could look out for unusual behavior, unusual patterns. And unusual patterns would, for example, prolong high energy consumption during night times, because that's where we quite naturally expect low energy consumption. And if you do that, if you do see that, then you could act upon that. And think about this. We capture data here in 5-minute intervals. Let me just zoom in a little bit. Take a very small data range. So you see here, this is at 4 in the morning, 4:05, 4:10. So it's 5-minute interval that we collect this data. Now, you get a very granular view. And the benefit of this is you can intervene much earlier than compared to, let's say, you get your energy bill at the end of the month and you notice an unusual high spike. You cannot react to that. I mean, you might be able to figure out what it was, but by then probably days and weeks have passed and you have wasted a lot of energy, possibly unintentionally, and that obviously impacts the climate in a negative way. Now, the other thing that if you want to get a bit more sophisticated, time series data is also a huge area of, let's say, analysis using machine learning and machine learning prediction algorithms. And if you attended the presentation of my colleague Hisham Galal, he spoke about machine learning services in AWS. And this kind of data is perfectly suited for learning usual patterns and automatically reacting if unusual patterns have been detected. So again, it comes back to data capture, data collection, and having the skills for doing that is very important, because once you have that data, it becomes very valuable to spot behaviors, to get ideas, what can we do to reduce our carbon footprint. So now let's come back to this discussion or the idea. Let me just remind you about this question. How much energy do we use and how much do we recover? So how good is the energy harvesting of that system? And to answer that question, I suggest let's go to a month that's actually cold in Germany, because you can see here that there is no heating in August because it's warm in Germany, like in the Middle East. And so you don't use that much. So let's go to January. That's more comparable. And then we get a view of the heating. Oh, before I do that, I want to mention one thing. I'm always talking about heating and recovering energy from an outside air heating. The same principle applies if we would look at a cooling system or air conditioning system that's being used for cooling in our region where we live, the Middle East. So if you need to put in energy to cool the air in a house, it's very valuable if you have the, let's say, the ventilation system running and you push out the used cooled air. You want to recover, you want to use some of that energy that's in there that has been basically put into this air to make it cool. You want to harvest this and you use the same system. You use a heat exchange. In this case, would be kind of a cooling exchange system, but it works with the same physical principles. And you cool down the incoming air a little bit before you need to add additional energy to cool it further down to a more comfortable level that you need in the house. And by doing so, you saved energy, you saved and reduced the carbon footprint of your cooling air conditioning system. And so that's important to keep in mind when I present this data here. So now I'm switching to January, and as we expected, I see a huge amount of heating energy, or energy is being used for heating. But I can also see that the green bars that represents the recovered heat or recovered energy is actually quite substantial. I mean, if I look at this specific date here, so that is 65 kilowatt hours is being used for heating, but I was able to recover 40. That's around 20, a little bit less than 25%. That's pretty good. So that means that between 20 and 25% of my required energy to keep the house warm, I was able to get that from the energy harvesting capability. And that's a nice example for collecting data to, first of all, understand whether a technology, in our case, heat exchange system or heat or energy harvesting system, is efficient, and if yes, to what degree. So you would be very clearly able to answer that question. And think further. So this kind of data now feeds to key decision makers that might, let's say, make decisions about what kind of technology to deploy or how to use different technologies in a district or even in a city. And oh yeah, thank you very much, Amar. Yeah, I just found this comment from you. Thank you very much with this tab. And so this is a good example of how data contributes to a decision-making process or how it provides insight. And so with that, we covered this. So with that, I would like to just to summarize. So just to reiterate, so coding is a very powerful skill, or let's say, coding, writing code, as well as data analysis, querying data. So this is the SQL querying language. So if you think about this, how you want to develop your future career, this is certainly a recommendation I strongly personally can recommend, and it's very powerful for helping initiatives, cities, or organizations that want to fight climate change with collecting data and finding new ways of combating climate change. The second point here, collected data helps to develop new ideas. Now, I believe when you collect data and you then analyze and you look at this, you will find a lot of surprises. You will find surprises in the sense of where energy is wasted. And you will be surprised by how much you can save without actually, I believe, personally believe, impacting your quality of life. I mean, quite often we say, in order to fight climate change, we have to reduce and change and reduce our behavior. But I believe a large amount of, let's say, savings can be achieved just by visualizing the data and identifying the wastage. Where has, let's say, electrical devices being left on running? And what does that mean? How much energy does it consume to leave on a TV, for example? Or how much energy does an old refrigerator consume? Or how much energy do you lose by having not a, let's say, an old building with not, let's say, well-maintained windows, and then you lose the cold air from the air conditioning system? And if you could fix that, how much could you save? And think about this, we are just talking about fixing things and identifying wastage, spillage, and we have not even touched the points where we could make a big impact by, let's say, thinking about completely new technologies. So that's a key message I want to convey, is data can unearth new ideas and surprises. And the other thing I want to leave you with is that cloud services allow you to start ideas very simple, very small. Keep in mind that what we built here in this demo is a Raspberry Pi, Python scripts, and using what's there in terms of data collection, and then using cloud services where you can basically you pay as you go, and that small amount of data that we're pushing around here, it's basically cents to the dollar that this costs. And when this picks up, so if these experiments to be proved successful, useful, when the data proves to be useful and you want to scale up, this is where the cloud really shines. Because what I demonstrated to you here, just pushing in the data from one device, can easily scale up to tens, if not hundreds and thousands and millions of devices that collect measurements data from a whole city. And then you can build a very comprehensive understanding how energy is being used in a city, and where areas, districts, and initiatives can be of can have a high impact in order to reduce the carbon footprint of cities today. With that, yeah, thank you very much for your time, and I hope I was able to provide some ideas for your Climathon in the coming few days and weeks. Thank you very much. And I think, do we have a few more minutes for questions?
Yes, we do have 5 minutes for Q&A. So